This is the second day of our review, getting ready for our official STAR test. So as we all know, we need to know these vocab words. So we're going to do this several times between now and the STAR test, keep them fresh in our heads. Now, posters. Try to do them without the posters, but if you need to, go look at the posters, all right? The linear one is in Unit 3 posters, but try to do them without it, see if you remember. The quadratic stuff is in the Unit 7 posters. Again, you can look at the poster, but try to do it without, see if you remember them. And then the exponentials is the last one that we did. They're Unit 8. So pause the video, go do this, see if you can remember. Okay, so everyone should be pausing the video. Hopefully you paused the video and now you're coming back and want to check your answers. So linears, counting up and over between 2 pretty points is slope, also known as the rate. That car went 80 miles an hour or 10 miles per hour. The oven is heating up 2 degrees per minute. Those are rates. So in a word problem, rate number is your slope. Where it crosses the y-axis, y-intercept, also the starting amount. Where it crosses the x-axis, also known as the x-intercept, 0 or solution. And this one, where it crosses the y-intercept, or where it crosses the y-axis, this equation, or this shape, when it crosses the y-axis, that's your y-intercept, also the starting amount. At time 0, what was the population before it started increasing? Quadratic, where it crosses the y-axis, also the y-intercept starting amount. So those did not change. When I let go of the ball, how high in the air was it before it went up and then came back down? The starting height is when I let go of it at time 0, and then it goes up in the air and comes down and hits the ground. Where it crosses the x-axis, and there's 2 of them, are your x-intercept, 0, and solution. So all those are the same. Now this one has a horizontal asymptote, so it does not have an x-intercept on this particular one, because this exponential graph gets closer and closer to this line but never touches it. So no matter how far out you go, it never ever touches or crosses it. So since this is my x-axis, there is no x-intercept, there is no 0, there is no solution in this particular one. Now sometimes it does cross the x-axis, but this one does not. Okay, the other parts on this one. This is called the horizontal asymptote, or asymptote, and the equation of it is always going to be y equals a number because it's a horizontal line, not a vertical line. And horizontal lines are your HOY, right? Vertical lines are VUX. H for horizontal, the slope is 0, and the equation starts with y equals a number. So your horizontal asymptote, the equation of that line will always be y equals a number. And the equation, y equals AB to the x. These two numbers being multiplied together, but this number has an exponent. That x is your time period. So when the x is the exponent, this is an exponential equation. It's either growing or it's coming down, decaying. So this is your time period, whether it's months, weeks, hours, whatever it may be. This is your growth or decay factor. If this number is bigger than 1, it's growing. If this number is smaller than 1, like 0.9, 0.2, it's decaying. This is your starting amount, or your y-intercept. So whatever this number is right there is that number right here. It's your starting amount. What was your population at time 0 before it started increasing? So there's that stuff. So we just want to remember if it's increasing and where the starting amount is. On the quadratics, they make a lovely parabola, and of course they have x squareds in the equations. Where it changes direction is your vertex. If it's a high point, it's a maximum. Had it been a low point, it would have been a minimum. Still a vertex, but a minimum. Y-intercept and starting amount we already talked about. X-intercepts and 0 solutions we talked about. The imaginary line down the middle through the vertex is your axis of symmetry. And because it's a vertical line, VUX, V-U-X, V for vertical, the slope is undefined. And the equation starts with x equals a number, so that will always be an x equals number equation, okay? We don't want to forget that basic vocab because that's critical to passing the STAR test. If you know your vocab and you know how to look at a picture and use your calculator to look at things, you can pass the STAR test. So that's why we keep going over those so many times. Now, what we're going to review today are the exponent rules. Where are these exponent rules on test day? When you have these questions that have exponents and stuff in them, right? We're going to do this math. You look at your reference sheet, and right here are properties of exponents. This is product is multiplication, quotient is division, powers, if you look over here, it's got parentheses with an exponent outside. Here's your division, the quotient 1. Here's your multiplication. So when it's a multiplication problem, if the bases are the same, you add the exponents. If the bases are the same in a division problem, you subtract them. If you have parentheses with an exponent outside and inside, you multiply the outside exponent times the inside one. They don't show it on this one, but you multiply it times all the ones inside. If you've got a fraction as an exponent, you can change it into a radical form. So it's just like going from, let's call it like decimals to fractions, right? You can convert back and forth between them. So you can have a fraction as an exponent, and you can also change it into a radical. And let's always use the bottoms out. So this bottom number goes outside the radical, the base goes inside and the numerator becomes the new exponent inside. And of course, we don't like negative exponents. And so how do you get rid of negative exponents? You move this whole thing to the other side of the fraction line. Right now it's on top. So if I move it to the bottom, it's now a positive n. So those are your exponent rules. So let's go over those on this. So here's the first one is just adding and subtracting monomials. So when we're combining like terms, we do not change the variables. We don't change their exponents, okay? So here we go. So if I have x squared y and x squared y, they are like terms because their variables are identical. So I've got 9 of these and negative 10 of these. So 9 somethings minus 10 somethings. Well, if you put 9 minus 10 in the calculator, it tells you negative 1. So I have a negative 1 something. I'm not going to change my somethings. They're still x squared y's. Okay? I'm subtracting 6w from 8w, so I start with the 8w and subtract the 6w from it. So this is the problem that they described, 8w minus 6w. 8 somethings minus 6 somethings. The somethings are the same, so I can combine them. And 8 minus 6 is 2 somethings. Don't change the somethings. So that's when you're adding and subtracting. These, however, are multiplication and powers and division. So these, you follow the rules on that reference sheet. So if you look at your reference sheet, when it's multiplication problem, they say add the exponents. So this is x to the a plus b, whatever those may be, right? If you have a power with the parentheses outside, it said to multiply them. So this is x to the a times b. So I'm kind of writing the rules here. If there's division and the bases are the same, it's x to the a minus b. You subtract them. How do you get rid of a negative exponent? You move it to the other side of the fraction line. Right now it's on top, so I'm going to move it to the bottom. Since there's nothing on top anymore, I leave a 1 up there, and now it's x to a positive a. And anything to the 0 power, if you put 5 to the 0 in the calculator, 2 to the 0 power, 11 to the 0 power, they all equal 1. So anything to the 0 power equals 1. That one is not on the reference sheet. That one you just have to know or put some numbers in the calculator and see what it tells you. So let's go do some of these. This is a multiplication problem. What did the reference sheet tell you to do? It said add. So literally, these rules are on the reference sheet. And all you got to do is when you get one of these problems, just look at the reference sheet and say, oh, I'm adding them. Oh, I'm subtracting them. Oh, I'm multiplying them. I'll pull this over here. We can see it. So this was a multiplication problem. Here's my multiplication problem, and we add them. All right. This one is also a multiplication problem. Now, the big numbers, the negative 2 and the 7, are just multiply as normal. So if you do negative 2 times 7 in the calculator, it is negative 14. Now, the a's can multiply with the a's, the b's can multiply with the b's. The bases have to be the same. So a squared times a to the third, what do we do when we're multiplying? We add them. So 2 plus 3 is a to the fifth. And then my b's, there's a little 1 sitting up there, you don't see it, and a little 1 sitting up there. So 1 plus 1 is b squared, which makes sense because b squared means you're multiplying b times itself. So b times b is b squared in shorthand. All right, next set. This is using the power rule, right? And what do we do in the power rule? You multiply them. What do we do in the power rule? You multiply them, right? Okay, so here's my little power rule. I've got parentheses with an exponent outside of it. That's when I use the power rule. So 3 times 2 is x to the 6th. And that's the only one that's inside the parentheses. Now, this, is that a 2 or 3? Oh, that's a 2. So 2 is on the outside, and this has got parentheses. So to do the power rule, remember everything in here has an exponent. We're going to multiply the outside one times the inside one. Now, this is a negative 2, so this is one you have to kind of be careful with. And now, it's a power rule, and it's also a multiplication problem. Which one do you do first? You're going to do the parentheses stuff first, because that's your power rule first. And then once the power rule is done, you're going to multiply the 2 together. Now, this negative 2 needs to stay inside parentheses, right? Because this negative 2 is being raised to the second power. So 2 times 1 is 2. Because I don't want to lose track that it's a negative 2, not a positive 2. So 2 times 1 is my 2. That's how I got that. And I just put the negative 2 inside parentheses so I don't lose that negative sign. 2 times 5 is to the 10, so this is m to the 10. And then we're still multiplying this thing times m3. But I've done the power thing. Now, this is all numbers. So if you put negative 2 in parentheses, square it in the calculator, it's going to tell you it's a positive 4. And then m to the 10 times m to the 3, what do you do when it's a multiplication problem? You add them. So 10 plus 3 is m to the 13. So hopefully these rules are coming back to you. There's a handful of these on the STAR test, and if you can get them right, this will bump you up into the A's and the B's as opposed to just passing. You don't have to do any of these and still pass the test. You can easily pass the test with the 30 easy questions. These are not the easy questions on the STAR test because you can't do these in the
Carson Haley,
Sorry,
if you are in the building, you
going
need
on.
to go to the front office. Carson Haley, you need to go to the front office. Thank you.
All right. So remember, you don't have to do these to get passing, but if you're trying to get into the A's and B's, you definitely want to be able to try to do some of these, right? Now, this is a division problem, so we're going to subtract the exponents. And it shows you right here on the reference sheet. Where did it go? There it is. Division problem. The bases are the same, A and A. You're going to subtract the exponents. Now, the big coefficients, they are just plain old math. So you have 27 over 42, and you put that in the calculator. Let the calculator reduce your fraction for you. It will tell you, when you put that one in the calculator, it's 9 over 14. So if you put 27 over 42 in the calculator, it will reduce it down to 9 over 14. So, and then you just look for an answer that has 9 over 14. If there's only one answer on a multiple choice, you don't even have to worry about the rest of it. Now, x's. I got x to the 5th and x to the 1st. It's division. When I'm done, I need to have a single x piece, and it needs to be a positive exponent. So I'm going to take the 5 and subtract the 1. That means I have x to the 4. Are the leftovers on top or bottom? There were more on top to start with, so that's where the leftovers are going. So I have 9x to the 4th on top, all over 14, and that's the answer you would look for. This one has no coefficients in it, so I'm just doing the y's. So here's the power rule with parentheses, and then there's a division after that. You're going to do the parentheses first because that's your power rule. And of course, the power rule says multiply the exponents. So if I multiply the outside one times the inside one, I think that's 2. Yeah, I'm looking close. Yeah, those are 2's. So this is 2 times 2, so this is y to the 4th. And now the parentheses are gone over y to the 4th. Now, when you're dividing, what do you do with the exponents? You subtract them. So you could just say, well, this cancels that out, and you're left with a big old 1. But more precisely, 4 minus 4 is y to the 0. And what did we say anything to the 0 power is? Yes, it's 1. You could have also just said, well, they cancel each other out, left when you're left with 1. Because y to the 4th divided by y to the 4th is 1. All right, next one. So now we have some negative exponents. Now, a lot of times I will move the negative exponents around before I get going, especially if it's a division problem. But this one, everything is on top right now. It's all over 1. So the negative exponent only goes with the x. The 5 has its own lovely positive exponent sitting up there. So don't move it. This 5x was not in parentheses. That negative 2 up here exponent only goes with the x. 5 has its own lovely positive number, so that negative 5 is going to stay on top. I can have negative numbers, I just don't want negative exponents. But to get rid of the negative exponent, I'm going to move the x to the bottom, and now it becomes a positive 2, and I'm done. That's all you're doing is getting rid of the negative exponents. You never want to leave an answer with negative exponents. So here we go again. I've got coefficients that I'm just going to do plain old math. 4 over 8 in the calculator, that reduces down to 1/2. So I let the calculator reduce my big coefficients, whatever the math is. Now I've got k squared over k to the 5th. So use subtraction, 5 minus 2 is k to the 3rd. Are the leftovers on top or on bottom? There were more to start with on bottom, so the leftovers are going to stay on bottom. And there's your answer. You got positive exponents, so you don't need to move anything. And the fractions have been reduced, so you're good. That's it. Here's our zeros. Now this 0 to the x power only goes with the x. The 7 has its own lovely 1 sitting up there. So I still have a 7 sitting here times whatever 0 to the x to the 0 power is, and x to the 0 power is 1. And 7 times 1 is just simply 7. So the 0 does not go with the whole thing. There's no parentheses around it. Had it been 7x to the 0, then this whole thing becomes a 1. But we don't have that, right? We had separate pieces. X to the 0 is a 1, and 7 to the 1 is still 7. And when you multiply them together, you get 7. Okay, here's another one. We've got division, and we got powers. We're going to do the powers first. Parentheses always go first. So your rule is to multiply. So 2 times 4 is w to the 8th over w to the 8th. This is division, so when you subtract, you get w to the 0. Anything to the 0 power is 1, or you could have just said they cancel each other out and you're left with a 1. Okay, so there's your review on exponent rules. We will practice a bunch of these tomorrow and again next week.